So let's start this periodic table I told you to. So very simple question I'm going to give you, which has been asked in NEET 2020. So basically, this question is important because twice, twice there has been question that is asked on this, and you need to remember this question. Basically, you can easily tell me the atomic number of all this after reading the name. Yes or no? Tell me.
Yes, sir.
Can you tell me what is the atomic number of the this? So un that means one, and nil that means zero, and again un that means one. 101, it's atomic number. If you are going for un nil trium, that means un one, nil that means zero, and tri that means three, right? So this is 103, and un nil hexium 106, and one un un unnium that means 111. Okay. Oh, and 101, 103. So you have to these all elements, these are IUPAC name, and these all elements have a name on its scientist. So basically, you need to remember this. And the answer, if you are going to see, identify the incorrect match. So only this one, D1, unnium is not this dermastadium, but all of them are correct. Like 101 atomic number has a name that is Mendelevium, and then unyl trium has a name that is Lawrencium, and unyl hexium has a name Seaborgium. Okay, so you have to remember 16 or 18 elements are there. So according to that, you need to remember. Please do this. So question number 2 is very easy, and I think you can do this easily. Siddhika.
1 second, sir.
So Siddhika is saying question number 2. Answer is Rishita and Siddhika both are correct. What about you, Akib? Any answer for this?
No, sir, till now.
Okay, see, first of all, you need to remember this neutral oxide. There are three neutral oxide: CO, NO, and N2O. Always remember this. So neutral oxide is three. Now we have amphoteric, and in amphoteric, the famous one is Al2O3 and BeO. So here Al2O3 is amphoteric, CO is neutral, and metallic oxide, barium is second group element, barium from magnesium group. So it is metallic oxide is your basic, and non-metallic oxide is your acidic. So you can see A is going in second. So A is going on second. And so this will be the answer. You can do like this. If you are confident about one of the matching and other are not given as it is that calculated, then you can easily do this. The rest you don't need to check if you are 100% confident. BAO, you can see this is your first. So first is given. Al2O3, amphoteric fourth. So C is fourth given. Cl2O7, that is non. Very easy. So this inorganic chemistry is like, if you know the concept, the trend, and the exceptions, you can easily handle this. Without wasting time, you can do this. Like in physical chemistry, you need to do calculation and all. Here, no calculation. Only you need to see the questions and try to remember the exceptions and the concept, you'll get it. Now this 3, 4, 5. If you have any doubt in concept of this chapter, you can ask me any topic or any.
Okay, sir.
Just look it up.
Any answer for question number 3, 4, 5?
Doing, sir.
Correct. Keep directly jump to the question number 5. What about 3 and 4? All of you. Oh, very good, Shilika, 4 and 5th. What about the third one? See, I'm going to explain this. The third one. The element Z is equal to 114 has been discovered recently. It will belong to which one of the following family, group, and electronic configuration? So very simple, you need to do the electronic configuration basically. And how you are going to do the electronic configuration? It will be a time taking, but it's not tough. It may be time taking. So let's say X is equal to 114. You are going to do the configuration. Either you can do in the form of 1s2, 2s2. If you remember this one, you can do in this form as well. So I'm going to show you the long method, and then we'll show the short method as well. So long method, like we will start from 1s2, 2s2, 2p6, 3s2, 3p6, 3p6, 4s2, 3d10. Up to this, you know how to do the electronic configuration. 30 atomic number. What about after this? So you can apply this trick to remember it. In NCERT, it is also given. If you will see it at the back of the chapter, atomic structure, 1s is here, and then 2s, 2p. This is your 2s and 2p. This is your 2s and then 2p. 3s, 3p. And then comes your 3d. Then comes your 4s, 4p, 4d. And 4f you can write. Now 5s, 5p, 5d, and 5f you can write. And after that 6s, 6p, and 6d. And you can also write this. It will be 7s, 7p, 7d, and 7f, something like this. You can write. Okay. Now see. First 1s, then 2s, then 2p, 3s, then 3p, 4s, and then 3d. And after 3d, in which you are going to put 4p. So maximum number of electron that goes in 4p will be 6. So 4p, 6, and after 4p, you have 5s. So you are going to fill 5s2. Since we have lots of electron up to 114, so up to this, it is 30 electron. Now it is 38. So this might look lengthy process, but you should go first through this, then we'll apply some trick and all. After 5s, you are going to apply this 4d, then 5p, then 6f. So 4d, 10, 5p, 6, and then comes your after 5p, you have 6s2. And then again, you are going to fill this one. Now you can see. Now you can see 4F you are going to choose. Oh, wait a minute. So 4F will not be there. We cannot use 4F here. So it will be like this, simple. I will tell you why. So what we need to do, very simple. After doing this, 4D, 5P, 6S, 5D, and then 5D10, and then 6P6, and then it is 7S2. After that, you are going to use this 5F14. 5F14. Let me count the number of electron first. Count number of electron pairs. So this is your up to this 30, and then 40, 48, 54, 56, 66, right? After 66, it is your 72, 72, and then comes your 74. After 74, what it will be? Please tell me. After 74, it becomes 74 and 6, 80, 80, and then 8, 88. I missed one thing. 88, we did up to this 5F14, and then 88, and then I missed this point. It was there, and 4D, 4, let it be 4F14, and then comes your. How many electrons did I count at that time? Rishita, Siddhika, 88, right?
Yes, sir.
So 88 plus 14, that is equal to 102. So 102 it becomes, and then comes your after this 102, and after this 5F14 we have 6D10, and 6D10, after 6D10, how many electron it becomes? 1112, and then 2 more, 7P2. Yes. So this is your all I want to say is that this is your configuration, which is, it will take a lot of time to do. So we will use some trick and all. So I needed to show you how you are going to do with a very simple method. You just need to do the configuration of this in the way that is given in NCERT. 1S, 2S, 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 2P, 3S, 3P, 3D, 4S, 4P, 4D, 4F. So this is your increasing order of electronic configuration like this. So you have 114 electrons. So in this way, you can do this. Now, this is up to, I'm going to show you. If you are going to see, radon is radon is what? Radon is basically your noble gas. So radon will come to this point. 6p6 up to 6p6. So how many electrons do you have in the outermost shell? That is 7s2 and 7p2. And since it entered, the last electron entered into the p, that means it is p block element, and the valence electron you can see, is your 4. So 4 valence electron, that means carbon family. So the answer will be your 4. So the answer will be your 4. Very simple it is. The best way to do this type of question is just remember some of the electronic configuration in terms of what do we say, noble gas. Like if someone will ask me what is the configuration of calcium, so I'm not going to do like 1s2 2s2 2p6. So we do like this in initial stage, like you will do like this 1s2 2s2 2p6, but when you will be expert, you are going to do argon 4s2. Argon 4s2. This will cover up to this will cover 1s2, 2s2, 2p6, 3s2, 3p6, 4, 3p6 up to this. So you need to remember these things like helium for after neon, it comes 3s2. After if you have argon, you have this 4s2. Here is helium, neon, argon, then comes what? Tell me. Krypton. So after krypton, it comes 5s2. Helium, neon, argon, krypton, then comes your xenon. It comes 6s2. And after xenon, it comes radon. What it will be? 7s2. Are you getting my point?
Yes, sir.
So 7s2, it was very easy. You also need to remember the atomic number of this. Do you know how to calculate the atomic number in terms of group? Like this has atomic number 2. Now, if you are moving to the second period, you need to add 8 and you will get atomic number 10 for this. If you need to move to the third period, again add 8 to this. Atomic number of argon is 18. If you are going to move to the fourth period, then you are going to add 18 and the atomic number of this is 36. If you are moving to next one, you are going to add 18 and you will get 54. Atomic number of xenon is 54. And if you are going to calculate atomic number of radon, you are going to add 32 and I think you will get 86 for this. Are you getting my point?
Yes, sir.
Yes, sir.
So this is called something magic number. This is how we calculate the atomic number. Like if someone will ask you, carbon is here and wait a minute, someone will ask you, what is the atomic number of lead? So if you know the element belongs from this carbon group. So carbon has 6 atomic number. If you will move to the next, that is silicon, you need to add 8 and you will get 14 atomic number. If they will ask you germanium, you just need to add 18 and you will get how much? 8 and 4, 12, 32. If you want to go to the next, so you are going to add 18 and you will get 8 to 10 and what it will be? Can you add this? What is the atomic number? 50, right? 18 plus 32, that becomes 50. And if you are going to calculate this, add 32 in this and you will get what? 82. So these are some magic number that you need to remember. So in the previous question, that was about 108 atomic, 114 atomic number. So you can see that this is your radon 7s2. If you are going for right radon, that means you already did for 86 electron already distributed. Then comes your 7s2. After 7s2, what comes? P. So it will be 7 whatever before 7 is before writing this, what you are going to do, very simple. So before writing 7s2, you have other things like 5d will be there. So 5d and 5f will also be there. So you are going to fill in this as well, 5f 14. And how many electrons now? 86 to 88, 88 plus this. Then comes your 5d will be there and 7p will be there, because you know the electronic configuration is on the basis of n plus l rule. So if you are going to do n plus l for this one, if you are going to do n plus l for this one, it will be 8. If you are going to do for this will be 8, and if you are going to do this will be 7, and if you are going to do for this will be 7. So after 7s, this will be filled. No, since both are same, both are equal. So this will be filled first, then comes this. After this and this will be filled first, and after, at last, this will come, in which 2 electron will go. Is that clear, everyone?
Yes, sir.
Okay, so
Yes, sir.
very easy. You should remember the atomic number in terms of this. So I'm going to take the answer. In this, A is also correct, and in this, noble gas. So an atom has electronic configuration. This you will place it in which group? So first, do you know how to calculate group?
Yes,
Rishita. Rishita, you are silent. What happened? Akib, do you know how to calculate group?
Sorry, sir, which one?
Group, how to calculate group number of any element?
No, sir.
Okay, so see, for group, we are going to discuss for group, for period, in which period it will be. What you need to do, very simple. Do electronic configuration. Do electronic configuration. If you are going to do the electronic configuration, you need to check highest principal quantum number. Highest principal PQ, and I'm going to write principal quantum number is equal to your period number. Okay, period number of that element. Now, if someone will ask me that sodium atomic number 11, in which period does it lie? So simple, I'm going to do the electronic configuration 1s2, 2s2, 2p6, and this is your 3s2. Now, principal quantum number is what? This first cell, second cell, third cell. This is your the number of n, that means shell. So it belongs to the third period. Are you getting my point, Akib and Rishita?
Yes, sir.
So tell me in which period this sulfur exists or this sulfur goes. Sulfur 16 it is silicon. I wanted to write but changed to sulfur. So its atomic number is
Third
16.
period again, sir.
Yes, very good. 1s2, 2s2, 2p6, 3s2,
3s2, 4s2,
3p4. No, not 4s2. 4s2 will not come.
3p4. Yes, sir.
3s2. So see the third period. And now you know, before calculation of group, you need to know how to calculate group number, group. How to calculate group? We need to know how to know which element exists in which block, which element exists in which block. So basically, before calculating or learning the concept of how to calculate group number, you need to know how to know the elements belong from which group. It is very important. So it's also very easy. The last electron enters whichever subcell. The last electron enters whichever subcell. Whichever subcell. Like in the first sodium one, you can see that the last electron entered in which subcell? S. So it belongs to S block. The last electron in this enters in which subcell? P. So it belongs to P block. Are you getting my point, all of you? Rishita, Siddhika.
Yes, sir.
So how to calculate period number? Just do the electronic configuration in neutral state. Neutral state is very important. If someone will ask you what is the period number of Na plus. So you are not going to do the configuration of Na plus, because if you are going to do the configuration of Na plus, you will get this. And according to this, this is your second period element, which is wrong. You are always going to do in neutral state. So you just need to do the electronic configuration, get the highest principal quantum number, that is your period number. And if you want to know the block, just do the configuration. The last electron enters whichever subcell, that will be the block. Now for group. For group, very easy. If it is S block, group is equal to valence electron. If it is S block, group is equal to valence electron. So that's why I told you it's very important to know from which block it is. Like sodium, you did the configuration 1s2, 2s2, 2p6. 1s2, 2s2, 2p6, 3s1. So you can see this is your S block and its period is third and the valence electron is 1. So it belongs from first group. Are you getting my point?
Yes, sir.
Now tell me the group of calcium. First, we are going to do the configuration, and I think you know the atomic number of calcium, right?
Yes, sir.
Please.
Sir, fourth period.
Very good. Let me know the block.
Second.
I'm talking about block, not group. In which block? Block, you know, periodic table has 4 blocks. S, P, D, F, that is block, right? So you
Yes,
did the
sir.
configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s2,
Four
right?
P.
So it is the period number is equal to your 4. If someone asks you which block, so the last electron entered into the S, so it belongs from S block. Now, if you are going to calculate the group will be what? What is the valence electron? Valence electron is the number of electrons present in last cell. Last cell is your 4th number cell, so it is second group. Isn't it easy?
Yes, sir.
Okay, the next F for P block. P block. Group is equal to number of valence electron. Number of valence electron, or in some books it will be written number of electron, number of ns electron plus number of np electron. Like what I want to say, valence electron, you know, valence electron is basically electrons in last shell, electrons in last shell. So I'm going to show you for nitrogen atomic number 7. You are just going to do the electronic configuration. All are based upon electronic configuration. Now you can see this is your 1s2, this is your 2s2, and this is your 2p3. So as you can see, there is 2 cell, first cell and second cell. So this shell is your last shell. That means valence electron. The electron present in this cell, S and P is 2 and 2 is written twice with S and P. S and P is subcell and 2 is cell. So this is your last cell. How many electron that you are getting? Just wait a minute. A little mistake is here. Yes. Number of valence electron plus 10. That is the formula for group number for D, for P block element. Whatever is the valence electron that you can see, group will be equal to valence electron of nitrogen is 5, since it is P block element, because last electron entered into P subcell. So 5 plus 10, that is equal to 15th group. Are you getting my point? Whatever
Yes, sir.
is the number of valence electron, you are going to add 10 in that and you will get the group number. And ns np plus 10, s that is 2 electron, p that is last cell 3, then 10. How much you will get? 15 group, isn't it? Please
Yes,
calculate
sir.
the group number of this, and period number, second period it is. Please do this. Very good, Atul. So group number is 14. You just need to do the configuration. 1s2, 2s2, 2p6, 3s2, 3p2. So the last electron, valence electron is 4 plus 10, that is 14, right? Yes or no?
Yes, sir.
So very simple. For D block and third period, it is very good. Rishita, are you getting all this?
Yes, sir. It's in the third group, right?
No, third period, 14th group.
Okay, sir.
So for D block, group is equal to number of electron in NS plus ND, N minus 1D basically. Whenever you are going to do the electronic configuration, whatever is the shell number of S and the number of shell of D will be lesser by 1 than S. Let's say I'm going to talk about a scandium has a atomic number that is 21, and that is your 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. Now, if you want to do like this argon, that will cover up to this 3p6. You just need to remember after argon what comes, that is 4s2, and this after this 3d1. Now you can see what I told you, number of electron in NS, that means last shell. This is the last shell. And D, what you need to, which D you need to take? Just lesser than 1, N minus 1. This is 4, this is 1. What is the number of electron? 1 here and 2 here. So the group number here will be third. Are you getting my point, all of you?
Yes,
Please
sir.
tell me the group number of iron. Okay, let me check it. Argon, and after this 4s2, 20, and then 3d6. So the group number is your 8th group. What will be the period of this? So period of this group is 4th period. Which block it is? D block, because the last electron entered into D block. Is that clear?
Yes, sir.
Okay, then comes your lanthanoid F block. For F block, I'm going to show you. For F block, there are two series. You have seen lanthanoid and actinoid. And I'm going to show you. They have same group, third group. They belongs from third group. This is your lanthanoid. If you have seen periodic table, it is written on the bottom, lanthanoid, and this is your actinoid. So group number is same. That is your third group. They belongs from the third group. And what about period? So period will be basically one is 6th and another is 7th. 6th and 7th period. You need to remember this. Atomic number 58 to 71. It is lanthanoid and it belongs from 6th period. 90 to 103 actinoid 7th period. And group is third for both of them. Third group. I think you can remember this, right? Let me know when you are done with this.
Minutes, sir.
Any answer?
No, sir.
Okay, I'm going to explain. The electronic configuration of an element is this. What is the atomic number? You just need to count the number of electron. Generally, what happens? Atomic number is equal to electron is equal to proton. What is the number of atomic number? So what do you need? 10 plus 10
15, sir.
plus 15. 15 is the atomic number. Okay, which is just below that. The question is not about what is the atomic number of this element which has a configuration, which is just below this. Do you know 15 is phosphorus? Yes or no? Yes or no?
Yes, sir.
And above this nitrogen is there? Yes or no?
Yes, sir.
Now, what I told you, when you are moving from second period to third period, third group, when you are moving from this is your second period, this is your third period. Okay. So when you are moving from second to third, add 8 in this and you will get 15. And then when you are moving from third to fourth, what you need to do? Very simple it is. You are going to add 18 into this. Let's say any element X there is 8533 is the atomic number. This is what I explained in the previous question, how to get the atomic number in in a group. Second to third, 8, third to fourth, 18, fourth to fifth, again 18. And after this 5th to 6th, if you are going to do, add 32, something like that. Is that clear? Again, the question is related to this. See, 33. What is the group of nitrogen 15th? Yes or no? Nitrogen belongs
Yes,
from
sir.
carbon is 14th group. If the atomic number of an element is 33, you got 33, which belongs from nitrogen group. That nitrogen is 15th group. It will be placed in the periodic table in the first group, third group, fifth group, seventh group. So it is talking about when they ask you this type of question and you got 15. So you have to add 10 by yourself and you will get 15th group. Sometimes it is called fourth group. That means basically if you are going to see periodic table, there will be a Roman numeral value of the group. So fifth group we can say. Is that clear, both of you, all of you? Siddhika, are you there?
Yes, sir.
Are you not able to solve this?
No, sir, I was struggling a bit.
Okay, no problem. Rishita, you are not responding today. You are not interested in inorganic chemistry, or you don't.
I didn't revise it properly, sir.
Oh, that's very bad. Okay, not a problem. Please do write all this. Ninth one is wrong. Ninth one is wrong. 10th one is correct. Any answer from okay?
No, sir. Getting wrong.
Okay, no problem. See, 13th group element, do you remember the name of the element in each group? Like with the help of some mnemonic and all.
Sir, is the 19th one, sorry, 9th one D?
No, no, not D. I'll explain that. See, this is your 13th group, and down the group, size increases generally, right?
Yes, sir.
Down the group, size increases. So the expectation that we have is like boron, aluminum, and then comes your gallium, then comes your indium, and then comes your thallium. But this is wrong. The correct one is boron, and then comes your gallium, then aluminum, and then indium. The rest part is same, only this interchanged. Why it is so? So gallium is basically the fourth period element, and there will be 4D. So due to poor shielding effect of 4D series, due to poor shielding effect of 4D, this gallium shrink or contract. That's why aluminum will be greater than gallium, and this is the correct. So the answer is your C for question number 10. That is correct, given by Siddhika. Now, when you are going to talk about this ionization enthalpy, can anyone tell me what is ionization enthalpy? What
The
is
amount of energy it takes to lose an electron.
takes to lose? Okay. Okay, tell me, is it ionization energy is endothermic or exothermic, or it depends, or what it will be?
Exothermic, I think.
Exothermic. What is exothermic, Rishita?
It releases a lot of energy. It needs a lot of energy, like endothermic. Sir.
Endothermic, actually, because in taking out the electron, you need to give some energy. So ionization energy is always endothermic reaction. Now, when you are going to see, the question is about lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Was neon is given? Yes or no? Neon is also there. So neon is there. Now, generally, how do I solve the question? By doing the electronic configuration and seeing that whether it is stable or not. So lithium has a configuration. I'm going to write 1s2, 2s1. Now for beryllium, it is 1s2, 2s2. Now for boron, it is 1s2, 2s2, 2p1. For carbon, it is 1s2, 2s2, 2p2. For nitrogen, it is 1s2, 2s2, 2p3. And for oxygen, it is 1s2, 2s2, 2p4. For chlorine, it is 1s2, 2s2, 2p5. And for neon, it is 1s2, 2s2, 2p6. When we are going to move in a periodic table from left to right in a period, left to right in a period, what happens to ionization energy? Whether it will increase or decrease, the trend, what does it say?
It increases.
So ionization energy increases. Yes or no? So this should be the maximum, then this, then this, then this, then this, like this. But what happens here? That is true that neon will have the maximum because its orbital is completely filled and it is stable. And if it is stable, that means it will not, it doesn't want to give its electron, because if it is going to give its electron, it will be unstable now. That's why it will have the maximum ionization energy. You have to give a lot of energy to take out the electron. Then come to the fluorine. Fluorine is the second most electronegative element. So then comes your fluorine. Now after that, oxygen is the second most electronegative element and nitrogen is the third most electronegative element. But if you are going to see the configuration in nitrogen, you have half-filled configuration. You have half-filled configuration, and half-filled configuration is stable than any other configuration. Like what is half-filled? P has 6 electron in the outermost shell, maximum electron 6. But here it is 2p3. 3 electrons are there, half-filled it is. That's why after fluorine, the maximum energy required to take out the electron, that will be nitrogen. Then come your oxygen, then carbon. Then comparison going to be happened between boron and beryllium. You can see it is fully filled in a way, 1s2, 2s2, it is fully filled, and this is 1s2, 2s2 and 2p1. So we can take out electron easily from 2p1 as compared to 2s2, which is fully filled subshell. So then your comes beryllium and then boron, at last your lithium will come. So this is the trend, neon, fluorine. So let's say let's check it whether which one is correct. So neon, fluorine, oxygen. It's wrong. Nitrogen will always greater than this. Neon, fluorine, nitrogen, oxygen, carbon, beryllium, boron. So the answer will be B. Is that clear? Siddhika, Rishita, and Akib.
Yes, sir.
Yes, sir.
Okay. Just wait a minute. Strengthen your inorganic chemistry. It will be very helpful to score good marks. Any answer for 11? So you haven't revised this trends and physical properties, chemical properties. Akib, in which of the following options the order of arrangement does not agree with the variation of property against it? Increasing ionic size. Can you tell me which one is having the largest size? Is it true or false? Not completely. No, in this periodic table, you have some uh, periodic table classification, like very simple. It is Dauvergne triad, Newlands octave law, and at last Moseley long form of periodic table. After that, you need to see S block, P block, and all. No, it's wrong, Rishita. The chapter is quite small. You should have done this. This is a correct one. Should I manage? How much did you revise, Akib? Siddhika, any answer?
No, sir.
Oh, very good. Okay, leave this. How much do you revise, every one of you? Up to which topic did you revise? You should do it completely now. Do the electronic configuration of this. Any answer?
Sir, for first one, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d9.
It's wrong.
So it will be 4s 1 3d10.
That is correct. Who said that?
So Rishita.
Oh, very good. Give it is an exception. Basically, the expectation is this: argon 4s1, sorry, 4s2 3d9, but it is wrong. It is stable in this form: argon 4s1 3d10. Please do the rest.
So for the second one, is it 4s1 3d5? Like at the end?
Yeah, the expected is basically something else. Expectation is for argon 4s to 3d4, but it is stable in this form.
Sir, for last one, 5s1 3d10.
Yes. So basically,
Okay.
the three of this I given was an exception. So be careful about the exception. Okay.
Yes, sir.
So Krypton 5s1 3d10. Please do revise, then you will enjoy this class of inorganic chemistry. Otherwise, everything will be like you won't understand. Okay, simple question I'm going to ask you. Which one is bigger, sodium or sodium plus? Size. Rishita, this question is from you for you.
Na is bigger
Na is bigger. Why?
because when you lose electrons, the
Cell also lost, right?
yeah,
Hmm,
yes,
yeah, something like that. So always remember, if I'm going to ask you Cl and Cl minus, which one is bigger?
Cl minus.
Cl minus.
Cl minus. So that means basically from here we can conclude anion is always greater than neutral or parent, and it is greater than cation. Yes or no? Can we conclude?
Yes, sir.
Okay, let me ask you Al plus or Al plus 2, which one is greater?
Al
A
plus.
plus.
Al plus is greater. The one which is having more positive charge, more small. That means very small, right? If I'll ask you O negative, O minus 2, which one is greater?
-2.
-2.
These are all inside, right? Now, the question I'm going to ask you, Na plus, Mg plus 2, Al plus 3, which one is the biggest one and the smallest one?
The bigger one is Na plus Al3 is smallest.
Yes, this will be the order of sides. Yes or no, Rishita?
Yes, sir.
The one which is having more positive charge is more smaller, and the one which is having more negative charge. Let's say if I'm going to ask you O minus, F minus, O minus 2, N minus 3, which one is the greatest one?
N-3 is the greatest and F- is the
Yes.
smallest.
So I call it जिस पे जितना ज्यादा negative वो उतना बड़ा. The one which is having more negative charge will be the largest one, and the one which is having the more positive charge is the smallest one. Because you know, after losing electron, proton will be as it is. So proton becomes powerful and it has more power to attract electrons. Less number of electron will be there. So nuclear charge increases. That's why it will attract with more force and it will contract the size. Is that clear, everyone?
Yes, sir.
Yes, sir.
So you are going to only attempt the question number 14, not 15. Yeah. Rishita, F negative and O minus 2, which one is greater?
Sir, that O minus 2 is greater, but all the others didn't make sense.
Yeah, so this question was in bonus. Only because all the options are not correct
Right.
and we needed to choose the correct one. You can see anion is greater than cation, but cation is not greater than parent. So this is wrong.
Yeah.
Cation cannot be greater than this. So this is also Na plus. Okay, this is also wrong. OF negative cannot be greater.
And
L plus
Al3
3, this is also
plus.
not. So this is the incorrect one.
So they can ask questions like this also.
No, basically it is the question is not. I don't think it is. Sometimes it is purposely, but it is not. Sometimes printing mistake and something like that happens. So that question goes in bonus. Okay, Rishita. So your concept should be clear so that